This is a revision videocast which focuses on the topic of energy. In this videocast we will be looking at past paper questions for the years of June 06 to June 09. Now the topic of energy can appear in both paper 1 and paper 2, so that it is important that you revise it for both papers. The first paper I'm going to look at today is the June 06 paper, so please turn to that one in your booklet. A metal is a good conductor of heat, but glass is a poor conductor of heat. Describe in terms of particles. So the important bit is in terms of particles, how the conduction of heat takes place in each of these materials. Well, firstly, looking at the metal. For a good conductor like a metal, the particle that actually conducts the heat are electrons. So free electrons gain more energy from the heat. They gain energy and carry heat through the material. And they pass on that energy via collisions with other particles. So it's the free electrons get you 1 mark, and they carry the heat via collisions, get you the 2nd mark. Now in a poor conductor like glass, the particle which is involved in heat transfer are atoms or molecules. Either word is suitable, but not electrons. So that's the essential difference, is that in metals it's electrons, and poor conductors like glass it's atoms or molecules. They transfer heat energy by vibrating more. And this is an important point, this vibrating idea, as opposed to in the first one with the metal, it was movement. We should add that in actually to the first one. Free electrons gain energy and carry heat via collisions as they move. So make a clear distinction between movement and vibration, and electrons and atoms. So atoms by vibrating. Those are the main 4 marks they're looking for there. So the key words in the answer to that question are electrons moving. You may mention collisions in a metal. And in a poor conductor, it's atoms or molecules transferring energy by vibration. If you refer simply to the more vague term particles in each of your answers, you won't gain marks. And do not, under any circumstances, refer to charge. This question is about heat conduction, not electrical conduction. So focus very much on transferring heat energy. The next part of the question. A large amount of heat loss from a house takes place through the walls. This heat loss can be reduced by filling the space between the walls with polystyrene foam. Explain how this reduces heat loss. Well, polystyrene foam is an expanded material, which means that it contains air, and that air is trapped within the material. And air itself is an insulator. Therefore, if you trap air in the space, and it acts as an insulator, it prevents heat loss by convection and also then by conduction, as it is an insulator. So the best answer, polystyrene contains trapped air, and it's important that you say that it's trapped air, because this means the air then can't move, which is an insulator. And because the air is trapped, it prevents convection, which, as you know, is the movement of particles in a fluid, and heat transfer. Okay, let's move on to the next part. Describe how the transfer of heat energy from hot objects to its surroundings by radiation differs from the transfer of heat energy from the same hot object to its surroundings by convection. So, radiation and convection, they're actually in bold in the question to draw your attention to them. The other word that I would highlight here is differs from. So how is radiation different from convection. Therefore, we must mention both. Well, radiation transmits heat by waves. Which means that it can transfer through a vacuum. Whereas convection involves movement of the particles, in this case air. So the main difference there is waves and movement of air particles. So you've got the difference between the two. Also, other answers which you could put in there but aren't quite as good are things like convection transfers heat only upwards as the hot air rises, whereas radiation transmits heat in all directions. But the best one is the fundamental idea of the difference between the waves and the movement of air particles. Now, the next part of that question is on the next page. The apparatus shown is used to determine the expansion of a liquid. The flask is heated, but the liquid level in the glass tube falls at first, before eventually rising as the liquid expands. We have a diagram which shows that. Explain why the liquid level falls at first. Well, let's have a look at the diagram. When we heat it, the heat comes in contact with the glass first, and that heat must be conducted through the glass wall of the flask before it reaches the water and begins to heat it. But when we heat the glass, it expands at first, which means there's more space inside the flask. Therefore, the water level in the glass tube will come down. Then, whenever the liquid itself begins to heat, the water level will gradually rise then and overflow the glass tube. So first of all, the glass expands at first, which creates more room in the flask, or more space. And the water level falls. When the heat is conducted through the glass, the water then heats and expands. So that explains the full process. So the glass expands at first, that's your first point, which creates more space inside the flask and the water level falls. And then when the heat is conducted through the glass, the water then heats and expands. So the level rises again. Would finish off that question. So that gives a full description of all that happens.